There are now two topics left that I want to cover for this review. The first one is the whole idea of the unit circle, which is a tool that we need to understand and use to be able to solve so many trig problems. This unit circle is based upon the idea of, in the world of trig, they define what I call special angles. And once again, I encourage you on the test, unless you've really got the unit circle memorized in your head crystal clear, you might want to take the first couple minutes on the test, create your unit circle. Now, I'm not going to do that, but I'm going to sort of make a unit circle, and then as I try and work through some of these problems, I'll point out the unit circle. So the unit circle is just a tool that helps us quickly determine the sine and the cosine of any of our special angles. So on the review, you end up with some problems like this. They say find the exact value. So you're not going to use your calculator. You have to know the exact value. The first one I see is cosine of pi over 4. Pi over 4 is the angle, and with the unit circle, we can have both radians and degrees, but a lot of radian problems. Pi over 4, you know, in each quadrant there's like 3 angles. Pi over 4 is the middle angle. It's also like 45 degrees. But this point here, the x is square root of 2 over 2, and the y is also square root of 2 over 2. Now the whole power and the key of the unit circle is, turns out the value of x is the same as the cosine, and the y is the same as the sine. So if this is my pi over 4 angle right here, and I'm asked for the cosine of it, I know this point right here, square root of 2 over 2, square root of 2 over 2, and the cosine's the x of it. I've memorized that x is square root of 2 over 2, so there's the cosine. How about sine 2 pi over 3? I first have to go find the 2 pi over 3 angle on my unit circle. 2 pi over 3 is right here. Then you have to know the coordinates of that point. X is 1/2, actually negative 1/2. Y is square root of 3 over 2. So if I'm looking for the sine, I go get the y value of that point, and right away I can say that the sine of 2 pi over 3 is square root of 3 over 2. And so on. Now they can get a little tricky. What about tangent of pi? Now the unit circle, each point gives you cosine and sine. It's nothing about tangent. But the key is, remember this key relationship. We can always rewrite tangent as sine over cosine. So the tangent of theta, or tangent of pi, is really sine pi over cosine pi. And I can figure those out. So pi is right here. This point here is negative 1, 0. So the sine is 0. Cosine's negative 1. Turns out the tangent of pi is 0. All right, let's look at a few more of these. How about, let me grab some ones that might be a little interesting. How about if you were asked for this? Cosecant of 7 pi over 6. All right, cosecant. It's not a trig function that we like to work with a lot. Matter of fact, I normally don't work with it. Matter of fact, what I'm going to do is cosecant gets paired with the sine. I'm going to go find the sine of pi over 6. Once I find that, I could just flip it, and then that's going to be the cosecant, right? So let's go find the sine of 7 pi over 6. Well, on the unit circle, 7 pi over 6 is right here. And that point is going to be negative square root of 3 over 2, negative 1/2. So the sine is like the value of y. So what's negative 1/2? So therefore the cosecant, I flip the sign. So the cosecant of 7 pi over 6 is negative 2. Any more interesting ones? All right, how about this? Let's do sometimes you may be asked to find cosine of a negative special angle. Cosine of negative pi over 6. Now normally in the unit circle, we don't have negative angles. So pi over 6 is right here. And normally right here ends up being 11 pi over 6. However, negative pi over 6 is actually this angle right here. Turns out negative pi over 6 is the same thing as 11 pi over 6. So therefore, cosine of negative pi over 6 is the same thing as cosine of 11 pi over 6. So that point there, square root of 3 over 2, negative 1/2. Cosines like the value of x, square root of 3 over 2. And let's do one or two more. Now here's one. Cosine of 7 pi. Once again, 7 pi is not on my unit circle. The unit circle goes from 0 to 2 pi. So what do I do about the angle 7 pi? Well, basically, you try and reduce this angle. It's like coterminal angles until you finally get a coterminal angle that's less than 2 pi. In other words, if you take 7 pi and you subtract 2 pi, you're down to 3 pi. Well, 3 pi is still bigger than 2 pi, so I subtract another 2 pi. Then you're down to pi. So what we're saying is the cosine of 7 pi is coterminal, or will have the same numbers as cosine of pi. So really this becomes a problem is what's the cosine of pi? Well, cosine of pi is right here, and it's negative 1. All right, so that's unit circle. Once you learn the unit circle, memorize it. It makes all these kinds, figuring out all these trig functions of special angles pretty straightforward. All right, now the last topic, and sometimes can sometimes be the trickiest are these trig graphs. And I have a couple of videos explaining a lot about trig graphs, so obviously I'm not going to go into it now. I'm just going to do some problems. So basically these first problems are, they give us equation of a trig function. And here's the questions they always ask. What's amplitude? What's the period, which we also call capital T? What's the phase shift? And then they always finishing by saying, and go ahead and sketch the graph represented by this equation. So the key to doing these problems is knowing the standard equations of these trig graphs. And it's a times sine in parentheses bx plus c, where a, b, and c are going to be numbers. And once we figure out what numbers a, b, and c are, Then we can go figure out all the rest of this stuff, and then we're able to sketch the graph. So let's just go ahead and do this problem, and you'll see how it all works out. So basically, A is 2. Looks like B is 2. And looks like C is 0. If you think of this as sine of 2x plus 0, you can see C is 0. So now here's the deal. The amplitude, it's always very straightforward. The amplitude is always whatever A is. So the amplitude is going to be 2. Now when we get ready to graph in a few minutes, I'll explain what amplitude is. The next thing we know, the period. Now here's this little formula you're going to have to memorize for the test. You'll not be given this little formula. The period is 2 pi over b. So 2 pi, and since b is 2, means the period is going to be pi. And then the phase shift, here's another equation you have to memorize. Negative c over b. So negative, now c is 0, b is 2, 0 over 2 is 0. So for this problem, there is no phase shift, which makes it a little bit easier. So now I figured out the amplitude, period, phase shift. Now I'm going to sketch it. So here's how I like to graph these. I go ahead and I look at my period. My period is pi, and I go ahead here and I draw my hash mark and mark it pi. Now based upon the period, I'm going to break this up into 4 equal sections. So if I cut it in half, half of pi is pi over 2. Cut it in half again, half of pi over 2 is pi over 4. Then if I cut this part in half, you end up with 3 pi over 4. So see in a minute, this is very strategic in how I marked my x-axis. The y-axis is very simple. The amplitude is how high and how low the graph is going to go. So basically, whatever the amplitude is, that's what I mark on my y-axis, both positive and negative. Now I'm getting ready to sketch the graph. And since there's no phase shift, I can sketch it the first time and pretty much be done with it. Now here's the key. You've got to look at what we've got. We've got a sine wave. A sine wave is one where when the angle is 0 right here, the sine is also 0. So my first point is 0. Now these points here are the key parts of one cycle of the sine wave. And what happens is it starts low. The first key point, the sine goes high. The next key point, it goes back to 0. Then this next point, it goes low, negative, and then back to 0. And then you sort of draw this nice smooth that is a sine wave, and actually that's a graph of y equals 2 sine 2x. Now let me check my key, just because I don't want to mess up and have everybody be confused. So this was yep. All right, let's do one more. How about y equals, now we got cosine 1/2 x plus pi over 2. Same questions. Find amplitude, period, phase shift, and then sketch the graph of this equation. So once again, the standard equation is A times cosine of bx plus c. So therefore, A in this case is 1, B is 1/2, and C is pi over 2. Now I know amplitude is A, so amplitude is going to be 1. The period is 2 pi over B, 2 pi over 1/2, and if you simplify this, it ends up being 4 pi. Once again, I don't know if I said it, but the period is how far you have to go until it starts to repeat, right? So here it's at 0 and it's going up. Here it's at 0 going up. That's why the period for this one is pi. So that's what period means. Then the last one is the phase shift. Negative c over b, so negative. Then c is pi over 2. And b is 1/2. If you simplify that, turns out the phase shift is negative pi. So now we've figured out sort of what I call the information or the facts about this function and this graph. Now we have to see if we can actually plot the graph. So once again, here's what I do. Now, when we have a phase shift like this, when I graph it, it's almost like in 2 steps. And I'll show you what I mean in a minute. First of all, these one is always the amplitude. Since it's 1, you just go mark 1 and -1 on the y-axis. Period is 4 pi. Just like I did last time, I go and I mark 4 pi, and then I break it up into 4 equal sections. So there's 2 pi, pi. And this helps me as I try and start to graph my wave, then I can tell when to go high and low. Now here's what I'm going to do. I'm going to go ahead and I'm going to graph this wave sort of ignoring the phase shift. I'm just going to graph this cosine wave ignoring the phase shift, and then the last step I'll include the phase shift. To try and graph them at the same time can become very confusing. I found the easiest thing is to graph it without the phase shift, and then you include the phase shift. So basically, we have a cosine wave. Cosine, what happens when the angle is 0? Cosine is 1. So cosine starts high, and then it goes to 0, and then it goes low, and then back to 0, then back high. So that's one cycle. So you notice I'm going to draw this in sort of dashed lines, because this is not my final answer. This is almost like a temporary . That's the graph of the straight cosine wave. What phase shift does, phase shifts takes this whole graph and shifts it to the left or right. And since the phase shift is minus pi, it says basically take this whole graph and move it negative pi, move it in the negative direction, a distance of pi. So what I do is I want to look on here and figure out, well, how far actually is pi? Well, here's 0 and here's pi. So really, pi is like 1 tick mark. That's how far I need to shift this graph. And I'm going to shift it in the negative direction. What does that mean? Here's what I do. So if 0 is here and pi is here, this is negative pi. I take this point, and I'm going to move that point a distance of pi to the left. So I put an empty circle here. I take this point, and when I shift it to the left, it goes here. This point goes here. This point goes here. This point goes here. And now I'm going to connect all these new circles I've drawn. Because that right there should be the actual equation graphed. The solid line. And let me check and see. And I'm looking, and yep, looks correct. All right, so once again, I have videos on how to do all this stuff if you need to have more detail. Now, the last couple of problems, we do the opposite. They give us a graph, and then they ask us to find all the information and then come up with the equation. So let me stop now, and I'll actually finish up with one more video where we go ahead and do that.